Today we are going to start with a question. In your school, what was your favorite subject? And mathematics. Or should I be asking this? How many of you understood mathematics? So why am I suddenly talking about mathematics today? The answer is Fibonacci numbers. So what are Fibonacci numbers? The concept of Fibonacci numbers was first introduced in India and later introduced to the countries in the West by Leonardo Fibonacci, an Italian mathematician, and he introduced it in 1202 when his book Liber Abaci, meaning the Book of Calculations, was published. The Fibonacci numbers go like these. You are given the first two numbers, which in our case could be 0 and 1, and then you add the 2. You now get the third number, which is 1. You then add the last 2 again. So 1 and 1 give 2, 1 and 2 give 3, then 2 and 3 give 5, 5 and 3 give 8, and so on and so forth. The function of the Fibonacci sequence looks like this. What is so magical about these Fibonacci numbers? Let me say it this way. Wherever your interest might be, it might be botany, wildlife photography, a person who just happens to love fruits, or you are an art lover or design lover. Still not satisfied? Let me pull out the big guns. These numbers are also a part of finance. See, now we are talking. Apart from all these fields, the simplicity of Fibonacci numbers can also help us learn a lot about the concepts of computer programming. In this video, we will cover 4 such techniques that calculate the nth Fibonacci number, and we will use Python for that. So let's begin. The first one is recursion. Recursion is a simple technique where we use a function to call itself. To get the nth Fibonacci number, we need the first 2 values, and then we just call the function recursively till we get the nth answer. We run the function for 10. That gave an answer pretty quickly. Not a lot to compute. Let's run it for 50. This is taking a while. So why did this happen? When we are using recursion, we are calling functions in this tree-like manner, and this is happening multiple times. If you look at this example, to compute the value of 4, we have to call f of 1 function 5 times. So this tree is providing us with a pattern that most of the values we need for our current computations are the ones we already computed in our previous function call. This is inefficient use of computers' resources. So how do we fix this? This problem can be solved by memoization. This is a concept of dynamic programming. Memoization works by storing the answers of previous function calls, usually to a dictionary in Python, and with a few modifications in the code we wrote earlier, we can implement this concept of memoization. So if we look at the code, it's very familiar and virtually no difference at all other than adding a dictionary to it. So how does it perform? Let's look at 10. Okay, that was expected. Now let's look at 50. That was fast too. So clearly it takes care of the problem that we were having with recursion. What about more numbers? Say 100.
500.
1000. As you can see, the memoization has improved the classic recursion technique, but it's also not going all that far. As you see, it crashed. Let's look at another approach, a more simpler approach. We are going to look at the concept of iteration now. We just saw recursion, which is a function that calls itself. Iteration, on the other hand, has a pointer that moves around the line. Both accomplish almost the same task here, but depending on our use case, one is usually better than the other. In this example, we will iterate over n elements and find out the value of the nth Fibonacci number. This approach is also very fast as it doesn't try to compute all values each time. Now let's look at the fourth concept. It's the concept of the golden ratio. Now, at the start of this video, we talked about how this sequence is found almost in everything that we see. Almost. Well, let's look at what's so magical about Fibonacci sequence. Here in this code, we are taking the ratio of two consecutive numbers. And look at the results. If we keep scrolling, we realize that the ratio becomes the same for all numbers found a bit later in the sequence. This irrational number is also known as the golden ratio. If you want to know more about the golden ratio, please check out this video by Numberphile. The link is in the description below. And we can actually use phi to calculate the nth Fibonacci number. The code is quite simple. The only difference is because pi is an irrational number, the answers we get for some of the larger numbers are not the same as we would get when computing with our regular methods. Okay, that was it for today's video. I do hope you found the concept of Fibonacci numbers interesting. If you like my video, please subscribe to my channel and let me know in the comments below what sort of videos would you like me to make. All right, final, bye. See you next time.